Now let's see how to classify the numbers which are normally given in decimal number system. So one way of classification is, see, I'll just explain you what are all the types of numbers available, and then we shall see what are the relationships among these numbers, types of numbers that we discuss. Now whenever when I talk about a type of number, it could be a part of other types of numbers as well. So what is the relationship between various types of the numbers? We shall see it later. First we shall see what are various types of numbers available. First one is natural numbers. You must be knowing about it. It is a set of positive counting numbers denoted by n. We generally use n to denote it, and natural numbers are the numbers which we use for counting. We don't have 0 in it. Other than 0, all the other numbers we have, like 1, 2, 3, 4, so on, right? And whole numbers, it is a set of all natural numbers including 0. So if to natural numbers, if I add 0, that is going to be whole numbers. And then integers, it is a set of all whole numbers along with negative numbers, which means if I take the whole numbers, along with the whole numbers, if I have the negative numbers as well, then that is going to be integers, right? So which means 0, 1, 2, 3, so on, it is all set of whole numbers. Along with the whole numbers, if I have negative numbers as well, it is set of all integers, right? And then real numbers, all the real numbers can be represented as a point on the real number line. Now if I take a real number line, you take any point that is nothing but a real number. For example, even between 0 and 1, there are many numbers present here, right? So all those numbers, wherever you can put a point, that is going to be a real number. For example, there can be 0.1, there can be 0.2, or there can be 0.1112, something like this. All these numbers are going to be real numbers, okay? Let's see rational numbers. These are the numbers which can be represented in the form of a by b, where a and b are integers and b is not equal to 0. For example, 1 by 2, 3 by 4, 2 by 9, 8, minus 4, these are all the numbers which I could write them as p by q form. Now you might just think how 8 is a rational number here. Even though it is written as 8, I could write it as 8 by 1, where 8 and 1 both are integers, that is the rule, okay? And minus 4 can be written as minus 4 by 1. So minus 4 and 1 both are integers, right? Now rational numbers can either be terminating or non-terminating. Now what do I mean by terminating is, if you look at the 0.5, right? So here you cannot say that, see this 0.5, so this is terminating, which means it is ending in just a fixed number of digits. You need not extend it further, you can just end it there. So you can write it in just 2 digits. That is why it is terminating. And now by looking at it, you might feel that it is not a rational number, right? Even if you write like this, 0.5 divided by 1, you cannot call it as a rational number as of now, because 0.5 is not an integer. See, both p and q both have to be integers. Therefore writing like this doesn't mean that it is a rational number. Then how to get the rational number is, this is not the representation, right? You can write it as 5 by 10, isn't it? 0.5 can be written as 5 by 10, or it can also be written as 1 by 2, right? Now you can see that both are integers, and now we are able to write a number as a p by q form in which both p and q are integers, and so you can call it as a rational number. Got it? And then same thing goes with 3 by 4, I mean 0.15, 0.75. If you look at 0.75, again you cannot write it as 0.75 divided by 1. You could write it as 75 divided by 100, which is going to give you 3 by 4. Anyway, you are able to write it as p by q form, and so it is going to be a rational number. Now these two examples I have taken here come under the category of terminating rational numbers. Terminating means if you look at them, they are not repeating, they are just terminating. Now there are other types of numbers which are non-terminating. For example, if you see this number 0.3333, it is going on, it is not terminating, right? So one other way of representing it is 0.3 bar, right? Which means 3 is going to repeat many times. Even though it is repeating many times, I could write it as 1 by 3. Okay, So how did I write it as 1 by 3 is, if you want to see the derivation, you can think of it this way: 0.3333 so on. Let us assume that it is equal to x, right? Let me multiply with 10 on both sides. Then what do I get? 10x equal to 3.333 so on. Now this 3.333 so on, I could write it this one as 3 plus 0.333 so on, isn't it? Now that could be written as x, right? Now what do you get? 9x is equal to 3. Now x is equal to 1 by 3. Therefore, whenever a number is non-terminating, right, if it is a non-terminating rational number, then you could somehow write it in terms of p by q. If you want to see one more example, let us say the non-terminating number is like this: 0.10101010 so on, right? Now if you see this, 10 is repeating itself, right? 10 is repeating itself. Now let us assume that this is equal to x. Then what I could write it as 100 into x. If I multiply both sides with 100 into x is equal to 10.101010 so on, right? And now clearly you can see that this entire thing 0.101010 can be replaced with x. Therefore what do I get here? 100 into x equal to 10 plus x, right? Now what does it mean? 99x equal to 10, right? From this I can derive that x is equal to 10 by 99. Got it? So again I am able to write this entire number as a ratio of two numbers, two integers in fact, right? Therefore we can say that a rational number can be either terminating or non-terminating. In case of non-terminating, if it is having any reoccurring sequence, then I could write it as a form of p by q. If it is not reoccurring like that, I will not be able to write it that way in terms of p by q. Okay. And the next thing is irrational numbers. Now these are not rational and they cannot be expressed as a by b, where a and b are integers, right? Now if you look at root 2, root 3, pi, all these numbers, they are non-terminating numbers. If you try to write them, they are non-terminating numbers, and we generally approximate them to closely to the representable number, right? We generally approximate the values of the rational numbers. So we'll write them till whatever point we could represent, and then we leave them there, right? And now if you look at this, root 2 is not a rational number. You cannot say that I can write root 2 as root 2 by 1, and since we are able to write it as p by q, you cannot say that it is a rational number. The reason is, even though you are able to write it as root 2 by 1, root 2 itself is not an integer. You can call a number as a rational number, you can put it as p by q, provided that both p and q are integers, right? But then here, if you are writing it as root 2 by 1 and root 2 is not an integer, then you cannot say that it is a rational number, right? And if you even try to convert into a rational number like how we applied here, root 2 doesn't have any recurring sequence. So what is the recurring sequence is? It is not having something like this, right? So it is not a sequence. If you see this, if you try to write root 2, it is 0.1414 and it will go on, but none of these numbers are going to, I think 1.414, right? So if you write like this, none of these numbers are going to repeat themselves, right? And so you cannot convert them into p by q form. Now the popular examples are all square roots of natural numbers except the perfect squares are all irrational numbers, and pi is also a famous example. Now if you look at pi, it is 3.14 so on. Now that number is not actually going to repeat itself anywhere, and it is non-terminating, and you will never be able to represent it as if it is a product of two numbers, as a ratio of two integers. So that is why you can remember this. They are the standard examples. They are all called as irrational numbers. Now they are always non-terminating. They will never be terminating. There are no particular repeating sets. So what is the repeating set means? This one. Got it? Okay.
Hi,
if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkey's ranking is 400. If you are happy to get into IIT Roorkey, then getting into universities better than IIT Roorkey is easier compared to getting into IIT Roorkey. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is, we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.